Welcome to the AIOps Evolution Weekly podcast. I'm your host, Sean McDermott. On this week's episode, we take a look at several use cases from our expert on the team, Bill Driscoll. Bill and I take a look at examples centered around a major university where they implement AI into the university's IT systems to streamline the usage of technology on such a large scale. We also explore another use case where AI was used on a massive scale in a data management company. Through AI implementation, they added in facility management systems to the project to aggregate data and consolidate it. Enjoy the episode. Welcome, everybody, to this week's AIOps Evolution Weekly podcast. I'm your host, Sean McDermott, and my co-host here is Bill Driscoll. Bill, how are you today?
I'm doing great, Sean. How are you doing?
I'm doing great. So today we are going to talk about use cases. We spend a lot of time going through articles and things like that. But last week we talked about developing an AI ops vision and a strategy. But I thought today would be really good to just go over a couple use cases. And I think you're the perfect guy for that, right? Because here at Windward,
Been involved in a couple.
you run a lot of our AI ops implementations, and so I'd love to kind of get your take on it. So let's just jump right into it and start talking about some things. So there's two general ones I wanted to highlight and wanted to ask you about. One is for a very large university system, so probably one of the top 5 university systems in the country, and the other one is a very, very large data center management company. So let's start with the educational use case first. So tell me a little
Mhm.
bit about the challenges that this client was trying to address, and
Yep.
so.
Great. Yeah. So this university is spread out across a lot of different locations. They have their main campus, some satellite campuses, a big hospital system, and they selected an AI ops solution to really. We talk about AI ops fitting in multiple areas, right? So you kind of have AI ops fitting in observability and monitoring and kind of collection of logs and whatnot. You have it in event management, you have it in automation. And so in this case, they were this large university systems that they had probably about a dozen different tools doing log monitoring. Splunk was an example of one tool they had. They had domain specific, like Oracle Enterprise Manager, doing monitoring, as well as they had a mail custom monitoring they were doing using different mail boxes, and a ton of, and like I said, about 6 or 7 other monitoring tools. And they had an operation center, a centralized operation center using ServiceNow and doing ticketing. And they had a very manual, either a manual process or some of these tools were actually auto opening tickets. And what they really saw is a need to do a centralized event management and consolidation of all of those monitoring tools into a centralized event management. They've been doing reading on AI ops and saying, we want to be able to apply some pretty complex logic on how they cluster these. They had some really good ideas on how to do a network focused correlation, sets of rules, I'll put in quotes. And they felt like this one tool that they selected really could provide that kind of clustering and bring those algorithms to bear, and then even go beyond that and do some more machine learning and feedback loop, to be able to kind of give them a much better centralized kind of operation console, but then also provide, significantly reduce the amount of tickets that were opened for their operation center.
Did they think that they were going to reduce any of the tools that they had, or was this really more about data processing?
No, this was not a. They were actually replacing a tool. I actually don't forget. It was one of the legacy kind of event management tools. So they were going to be replacing that, but they were not eliminating any of the kind of source monitoring tools that they were using. So this really covered. They were doing some application monitoring, server monitoring, some monitoring in the cloud, that we were pulling events in from. They were doing logs. This was a heavy network focus, and but they really were kind of introducing this event management layer, to sit between all of these monitoring tools, generating lots of noise and lots of information, to really reduce that noise for the ticketing system and their incident management processes.
So I think one of the key takeaways here, right, is that an AI ops deployment is not necessarily going to lead to a consolidation of tools. I mean, it may or may
Mhm.
not, But in this case, it's not, because a lot of these, it may replace one tool, right? Your legacy
Hmm.
manager is now being replaced by this AI ops tool, but all the source data coming in through all these different unique monitoring solutions stay
Hmm.
intact. So if you're looking
Yep.
at it from that perspective, there's not a ROI. So where does the ROI? Where were they thinking the ROI was going to come from in this type of implementation?
Yeah, I mean, it really was reducing the manpower, the time, the hours that it took to deal with all of these different alerts that were coming in individually. So examples, I mean, emails were being sent out to people's inboxes to whenever, with reports on a lot of different data and some level of kind of thresholding that generated this email, and they just needed to look at it. And the reality is there'd be we talk about like an event storm. There would be email storms, because there was just too many emails being sent out at once. And so I think it did two things. It reduced the amount of time and hours spent having to sift through all of the individual alerts, all of the different look at 10 different tools. That was on in the knock, at least, to have 10 different tools open. The domain experts still could use some of those tools. So it reduced those hours it took to kind of get to what's real and what's actionable. And then it also just cut through the noise. So it sort of focused action on actionable alerts and actionable incidents that needed to be resolved versus a lot of things just being missed. And so one of the big drivers was reducing overall outage time and reducing their overall mean time to restore. And we did see that, as we sort of finished the project and checked in about 6 months later, I don't have the numbers, but they were definitely seeing a reduction of both of those and a lot more focused action as they started, continuing to kind of introduce more algorithms and clustering to even further reduce it.
So when they were, was this client, a mature client? I mean, did you feel like when you were working with them that they really understood what they were getting into from a complexity perspective, or were they really relying on your team to do a lot of the heavy lifting and a lot of the, kind of
Yeah.
forethinking of what needed to be done as far as designing models and things like that?
Hmm. I think, well, you brought up the models I was going to start there. I think from a designing models and kind of knowing what they wanted, they were extremely prepared and had specifically what they wanted, which was a pretty complex. That was way more than we've seen from any others. I think when it came down to the implementation, I think like the data itself and interpreting the data and also understanding even the data and the enrichment that we were doing that sort of drove those models. I think that's where we sort of got much more involved and had to kind of drive and show them, all right, we're having challenges with getting this data. Some of the assumptions you made in your model, that there's gaps in the data. How do we handle these use cases? And so all of the things really, I guess, around the edge in terms of the complexity of the interfaces to collect the data, the filtering of the data. In some cases, one data source it turned into 12 data sources, and then the enrichment of that data was really driven off this internal. They called it a NetDB or network database that they had. A lot of that data wasn't as clean and had a lot of one to many and many to many relationships that we didn't expect, and so we had to tweak their algorithms. But from a understanding they wanted to show the impact of servers, the impact of applications when there was a network problem, and they had that modeled out very well, and we ended up implementing in a very effective way.
Yeah, I think what you're talking about is very common, right? Another example, different use case, a project that I was working on just recently where we were integrating into their ServiceNow database, their
Hmm.
CMDB, and there was a lot of emphasis being put onto that and using that data from the CMDB to make decisions on the other product side. And
Hmm.
as we connected into the CMDB, we realized that there was just a tremendous amount of data that just wasn't there, right? So
Yeah.
an object may have been provided, but it didn't have the vendor name. And if it doesn't have
Hmm.
the vendor name, then when we turned on the spigot and got 10,000 CIs coming in, and we were like, hey, we know that we don't need Microsoft, any of the Microsoft products. We want to filter those out. We couldn't because the vendor's name wasn't there. And so I think that's a really big lesson to be learned through here is that,
Hmm.
as we've talked about before, AI ops is all about the data, right? And the data sources are critical. And
Hmm.
underestimating what the data sources are, how many you have, how clean is the data, how usable is the data, is uh, very, very, very common in these AI ops deployments, and
Yeah.
it really does shine a light on the um, the integrity of the data and the data sources and the clarity of the data.
Yeah, one of the things we sort of compromised on taking on some additional scope, but then having some of it funded was handling that data quality. We sort of realized that we couldn't have clustering or the algorithms that they had not happening because that resulted in them losing visibility. But there were, let's say 10, 5, 10, 15% of of algorithms that were not being conducted because the data wasn't good, right? And so in our data load that they did kind of daily, into a custom database, we had to do all kinds of data quality and generate alerts for any kind of anomalies that we saw or any kind of gaps that we saw in the data, so they could resolve that. And so really, I think the best way to kind of deal with cleaning your data and doing data quality is to use it. But then you need a data cleanup and data quality sort of initiative along with that to make sure it is usable and continues to be used and trusted.
So regarding and you touched on this earlier a few minutes ago, but let's call it out specifically. What were some of the results of this project, and some of the measurable successes that they saw from this?
Yeah, I think measurable goes back to reduced outages. So I don't have the numbers here in front of me and coming into this, but they definitely reduced the time. That wasn't they didn't have less outages, but the number of the time the outages were down. Was what definitely went down. Mean time to restore went down. Mean time to detect definitely went down, and the number of incidents that were being opened went down, as well as the amount of I guess proactive. And I don't know if they measure this specifically, but the amount of incidents that were being kind of worked because they were generated by the knock, and auto generated through their event correlation system or their AIOps system, versus they were being reported from the customer. And so they did provide a good number of anecdotal sort of stories about, hey, the gentleman would call me and say, hey, by the way, just wanted to let you know, we just, the system detected this outage or detected this issue. We were on it and working in it, had it resolved before any customers even called us or recognized it. So they definitely were getting some wins like that, and definitely measuring that in their really using ServiceNow to kind of measure that data.
Yeah, I think the other thing that gets lost in this, and it's hard to kind of put into the ROI, is time wasted by other people, right? So we know
Hmm.
that during these outages, a lot of people get involved. In the higher priority outages, the more people involved, and it's not necessarily a good thing because a lot of these people shouldn't be involved. And
Hmm.
your example of them email blasting everything out is a really good example of somebody who's, say, on the DB team or the app team or even the network team, right, that is now getting 30, 40, 50 emails a day coming out of the monitoring system, and they have to go through and look at every one of those, right? And they have to go through
Hmm.
and they got to open it up and look at it. And let's say it takes them 30 seconds. I mean, that's a half an hour a day that they're spending
Yeah.
looking at stuff, and all of them may be application related issues, not network issues, but they have to go through and check them and see the data and basically say, okay, I don't need to be involved in this. Or they get sucked into a call and they're on the call for an hour, and meanwhile it was never really a network issue in the first place. So
Hmm.
there's a lot of ancillary wasted time that goes on in these environments where you can't pinpoint the problem as fast as possible or as accurate as possible because you just can't process the data enough. So you bring everybody together and you process it through committee. Right now
Yeah.
with AI ops, they can process the data much faster, more data, more granular, and really narrow down. Say, hey, we don't need a network team on the call. Let's get the application and DB teams on, and we'll take it from there.
Yep, that's exactly right. And I think getting that collaboration, whether it happens in your ticketing system service now or it can happen in the operation, and getting that kind of chat and like all that information's kind of already been correlated and in one place, is critical. And that was kind of one of the features they used of this product, and we're able to use more effectively than even some other customers using the product.
Awesome. All right, so let's move on. Let's move on to the second one. Let's talk about
Yeah.
this data center management company. So, very large data center management company, 200 some data centers all over the world, providing cloud services, co-location services, interconnect services, everything you would think
Hmm.
as a database or a data center provider nowadays. So let's talk about it again. So I'll ask the same question I started
Yeah.
off before. What was the challenge that they were trying to address with
Yeah.
this AIOps implementation?
So this was very different than a traditional sort of IT monitoring. This was a customer that actually did have an AI ops solution that they were implementing on the IT side. It started there, but then they saw a much bigger use case in facilities management. So this is monitoring the alerts that come out of building management systems, which is about power and electrical and batteries and water cooling and mechanical systems and heating and cooling. So all of that kind of data that all sort of is sort of all being monitored by what you might call controllers, sort of aggregating up into building management systems. And these may be in one room, or you may have some that's covering a whole bunch of rooms, or one that's kind of covering, consolidating it all into one facility. And they really saw a need to consolidate these alerts coming from their global distribution of hundreds of data centers they manage the facilities for, and bring that all into one place so they could bring what they call do a global sort of alarm distribution system. The end customer of this, or the user of this, where actually the tech was not any kind of centralized knock so far. It's really the end technicians that need to go out and do the truck roll, or need to go out and resolve this issue, or replace a battery, or resolve the power system or the electrical. And it's very high touch, hands on system with these with one of these building management systems. And so the purpose of this was really to be much more intelligent in centralizing and standardizing the management of what deems a truck roll, what deems putting a technician on site or sending somebody out to a cage, because so much of this needed to be done kind of with physical on presence. And so that was the goal, was to take all this information in and start to do intelligent clustering and start to do intelligent consolidation of alerts to get really the ones that needed to be the pages. They use the word pages, the pages that actually had to go out to the technicians.
Yeah, this is an interesting use case, right? I think because we talk so much about database monitoring and infrastructure monitoring, like networks and
Hmm.
applications, but there's a ton of data coming out of sensors, right? And
Yeah.
and power, you know, I mean, if you don't know anything about data center management, the power systems and facilities cost take up about 50% of the capital costs of running a data center.
Oh yeah.
So, uh, and power management is critical, right?
Yeah.
And it's critical
Well,
to the
this
cost.
company,
And
yeah, I'll
yeah,
just jump. I'm going to just interrupt. Yeah, I mean, they said when we brought up, about going back and doing the IT use case, they're like, we don't spend any money on IT. Like all of our money, if we could spend money on facilities, that's our business. They're going to save money on power,
mhm.
cutting power and reducing that way more than they're going to save money on IT expense. So,
Yeah,
yeah.
absolutely. And you have the same issue, right? You have massive power banks in these data centers, and if you're going to basically send some guy down the hall, and down the hall maybe like the size of a football field, and then down the stairs and back up to another hall to another to replace a battery pack that wasn't necessarily the issue, then you're just wasting a lot of time there. So
Hmm.
so let's talk. Since this was such a high priority project, how involved was senior leadership in the implementation?
I think it's a mix. I think with this, there wasn't. We definitely had the sponsorship and the support of kind of I guess probably more at the operational level. But this was budgeted, like I said, much easier than on the IT side. To get the funding and budget for this, to try to centralize this, because that's what they saw as their business. And I think we've talked about when you make the problem not about IT. It's not an IT problem. It's a business problem. It's about the delivery and the cost of running business that you're going to get funding. And so I think there was never been a challenge with getting the funding and supporting this and getting that centralized visibility. This also was part of a number of acquisitions. So, senior leaders saw they acquired several different other companies that were doing data centers, facilities, and they wanted to consolidate that. And so I think we had the full kind of support of the senior leadership. We worked with really the VP or director level of operations, and then the person under that person that kind of ran the tool, the kind of responsible for the tools and automation.
One thing we talk about a lot on this podcast, right? Again, is the data, right? And how do you integrate into the data, and then how do you build integrations into other systems once the data has been processed, and so how do you get information into centralized chatbots or environments like Slack and things like that, notification environments, communication, collaboration, or into ticketing systems? Were there a fair number of integrations involved in this project?
In this one, unlike the other one, it was a lot less. There was really two main ones. One was each of these data centers has their own building management systems, from like Schneider and drawing blanks now and the other names, but there was about 7 or 8 different building management systems that we worked with, and so each one of them might have a REST interface, an SNMP trap interface, and so we managed through each of those kind of integrations, and then within that was parsing the data. What does the alert that we're getting actually look like, and needing to parse that to kind of get into the standard common kind of data format. So that was a big part of it, what we call like the ingestions. There really wasn't any enrichment, which is the typical part of this. We weren't integrating. We looked at, could we integrate with the CMDB, or could we integrate with some other database? They don't have that yet. So they are working towards that. And that is something we're going to start getting involved in this coming year, is sort of a centralized building kind of database that we'll start to leverage. We integrated with the system we implemented kind of when it got deployed with a notification system as well. It's kind of the second half of the alert distribution. And that really provided the actual text and the actual messages and the emails, and handled the communication, two-directional communication with the text. And so the system we implemented was the centralized event management system that got intelligent events, clustered events out to this notification system, and then the notification system sent that on. And so there was a bidirectional kind of sharing of IDs between and status between the notifications being sent and the status of the alerts in the event management system, or the AIOps system. I think down the road they are a ServiceNow shop, and so I think they're looking at one, maybe using the CMDB, using maybe this global database, and then getting it more integrated with their ticketing or incident management system versus just doing notification, and which is what they do today.
Yeah, I think in the end, right? 1 + 1 = 3, right? That's what you're trying to get to. Is that how do you get these systems to work together in a way that they provide much more value than the sum of their parts?
Yeah,
and
right.
I think that's pretty exciting. So these are great. These great use cases, and I hope we can. We'll do this a little bit more often, because I think it's really good for the audience to just have examples of what's going on out there and how people are using AI ops, and kind of visualize how they might be able to do something, and take something away of hey, we have a very similar situation to this, and I like that point that was made. So thank you, Bill, for going through all that, and we'll do it again soon. So with that, I wanted to wrap up this today's episode. So Bill, thanks again for coming. You're always here, but thanks
Thank
again
you.
for talking about these use cases, and we look forward to hearing more, and we will see everybody next week. Good day.
Yep. See you next week.
Take care. Bye.